Professor Belfrost's science class is back.
Oh, hi, welcome back to my channel again. And today we'll continue on our first chapter on chemistry and we'll finish it up today. Okay, so still in the chapter on matter, physical, and chemical properties, elements, and compounds. Okay, so let's focus on ion and molecular, covalent compound today. So let's review a little about our discussion last time. So in ordinary chemical reactions, the nucleus of each atom and thus the identity of the element remains unchanged, but electrons can be added to atoms by transferring from other atoms or lost by transferring to other atoms or share with another atom. So atoms of many main group metals lose enough electrons to leave them with the same number of electrons as an atom of the preceding noble gas. So when atoms of non-metal elements form ions, they generally gain enough electrons to give them the same number of electrons as an atom of the next noble gas in the periodic table. Moving from the far left to the right in the periodic table, the main group elements tend to form cations with a charge equal to the group number. On the other hand, moving from the far right to the left on the periodic table, elements often form anions with a negative charge equal to the number of groups moved left from the noble gases. Transition metals and some other metals often exhibit variable charges that are not predictable by their location in the table. When electrons are transferred and ions form, ionic bonds result. Ionic bonds are electrostatic forces of attraction, that is, attractive forces experienced between objects of opposite electrical charge. When electrons of certain molecules form, then covalent bond result. Covalent bonds are like attractive force between the positively charged nuclei of the bond atoms and one or more pairs of electrons that are located between the atoms. Next point, when an element composed of atoms that rarely lose electrons, metal, reacts with an element composed of atoms that rarely gain electrons, a nonmetal, then a transfer of electrons usually occurs producing ions. In every ionic compound, the total number of positive charges of the cations, okay, the positive ion, equals to the number of negative charges of the negative ion. Thus, ionic compounds are electrically neutral overall, even though they contain positive and negative ions. Many ionic compounds contain polyatomic ions as a cation, the anion, or both. As with simple ionic compounds, this compound must also be electrically neutral and so their formula can be predicted by treating the polyatomic ions as created. Many compounds do not contain ions but instead consist solely of discrete neutral molecules. Whereas ionic compounds are usually formed when a metal and a nonmetal combine together, covalent compounds are usually formed by a combination of nonmetals. Okay, so done. That's previously. So we've covered the first basic. Now let's discuss the chemical nomenclature. Okay, about the ionic and the molecular compounds. Okay, so nomenclature, collection of rules for naming things, very important in science and in many other situations. The symbols of these are binary compounds, just containing unidentified elements, but we'll also consider how to name ionic compounds containing polyatomic ions and one specific very important class of compounds known as acids. We'll limit our attention here to organic compounds, compounds that are composed principally of elements other than carbon, and we'll follow the nomenclature guidelines proposed by IPAC. And how about the organic compounds? Actually, this will be treated in a specific chapter on organic chemistry because organic chemistry is actually quite a wide topic. So we should dedicate a single chapter on it, okay? Only for the organic chemistry alone. Okay, so great. You have done that. So now, to name an organic compound, we need to consider the answers to several questions. First is that, is a compound ionic or molecular? Then if the compound is ionic, does it matter from ions are only of only one type? or more than one type? Are the ions monatomic or polyatomic? If the compound is molecular, then does it contain hydrogen? If so, does it also contain oxygen? From the answers we derive, then replace the compound in appropriate category and then name it accordingly. Okay, so let's start from compounds containing only monatomic ions. So the name of a binary compound containing monatomic ion consists of the name of the cation, okay, the name of the metal, followed by the name of an ion with the suffix IDE, ite. So there are some examples you can see, such as sodium chloride, potassium bromide, also calcium iodide, and so on and so on. Okay. So compounds can also contain polyatomic ions, and the naming actually is similar to those containing only monatomic ions by first naming the cation, then the anion. So here's the example. For example, we have calcium sulfate, okay, magnesium phosphate, we have sodium bicarbonate, and many more actually. Okay, so most of the transition, okay, we have done with polyatomic ions. Then transition metals, how about the naming with transition metals? Okay, so most of transition metals and some main group metals can form two or more cations with different charges. And this is very crucial. Okay, so compounds of these metals with non-metals are named with the same method as compound of the first category, except that the charge of the metal ion is specified by Roman numeral uh, in parentheses after the name of the metal. So the charge of the metal ion is determined from the formula of the compound, the charge of the ion, the anion. Here's the example. So consider binary ionic compounds of iron and chlorine. Okay, so iron typically exhibits a charge of either 2 or 3 positive. Okay, and the two corresponding compound formula can be FeCl2 and FeCl3. Okay, so the simplest name, iron chloride, will actually become ambiguous in this case because it can represent both FeCl2 and also FeCl3. So in the case like this, then the charge of metal ions included as a Roman numeral in parentheses to immediate distinguish which one actually we want to tell the reader about. Okay, so we can state like iron 2 chloride or iron 3 chloride respectively. Here are some examples for you. So we have, for example, mercury 1 oxide, mercury 2 oxide. We can say tin 2 fluoride, tin 4 fluoride. Actually, there are some out-of-date nomenclature used that the use suffix of IC and OUS to designate metals with higher and lower charge. For example, iron 3 chloride is actually previously called ferric chloride, and iron 2 chloride actually was called ferrous chloride. But this has been abandoned, but though it has been largely abandoned, it's still used in some industry. So you can you still need to memorize some of the commonly used name in industry. For example, SNF2, it is tin 2 fluoride, right? And SNF4, okay, it is tin 4 fluoride. But previously they are called uh, stannous fluoride and also stannic fluoride, okay? Sometimes it's still used today. Okay. Okay. Next. So ionic compounds that contain one molecules integral components of your crystal called hybrids. And the name for an ionic hybrid is derived by adding a term to the name for the anhydrous or not hydrogen compound that indicate the number of water molecules associated with each formula of each formula unit of the compound. Okay. So we actually just need to add a great prefix, for example, mono, D, tri, tetra, penta, hexa, hepta, octa, nona, deca. Okay, very easy actually. For example, the anhydrous compound copper 2 sulfate also actually exists in a hybrid form containing 5 water molecules and also it can be named copper 2 sulfate pentohydrate. Okay. Also, washing soda is the common name for a hybrid of sodium carbonate containing 10 water molecules and the systemic name for this is sodium carbonate decahydrate. Okay, very simple, right? Formulas for ionic hybrids are written by appending a vertically centered dot, coefficient representing the number of molecules, and a formula for water. For example, copper 2 sulfate pentahydrate, that is CuSO4 dot 5H2O, and sodium carbonate dihydrate, it is Na2CO3 bullet dot 10H2O. Okay. Okay, so the bonding characteristic of inorganic molecular compounds are different from ionic compound, and they're named using a different system as well. Okay, so the charge of cations and anions dictate their ratios in ionic compounds. So specifying the names of the ions provides sufficient information to determine chemical formula. But for covalent bonding, because actually there are significant variations in combination ratios of the amount of the atoms in a molecule, then the name of molecular compounds by explicitly identify these ratios, not like ionic compound. Okay, so actually, when two non-metallic elements form a molecular compound, several combination ratios are possible. For example, for carbon and oxygen, it can make a compound like CO or CO2. And since these are actually different substances with different properties, you need to distinguish them. Okay, so we have to designate a specific naming method for this. So the name of the more metallic element, the one for the left and on the bottom of the periodic table, is first, followed by the name of the more non-metallic element, and its ending changed to the suffix ide. Okay, so the numbers of atoms of each element are designated by the Greek prefixes as before. Okay, mono, di, tri, okay, tetra, penta, and so on. So okay. So when only one atom of the first element is present, then the prefix mono is usually deleted from the part. So CO is carbon monoxide, and CO2 actually is a subscript. Yeah, it's not the regular two. It's called carbon dioxide. Okay. Here are other examples that you can read by yourself. But actually, there are a few common names that you will encounter as you continue study chemistry. For example, although NO is often called nitric oxide, you have learned before, right? It's ferric oxide. Okay, so actually, it's not the proper name. So the proper name is actually nitrogen monoxide. Similarly, you have N2O. Actually, sometimes it's called like nitrous oxide. Actually, this is not the proper name, but you should use the name dinitrogen monoxide. Okay, and also for example H2O, you'll not call this dihydrogen monoxide, right? You'll call this just water. Okay, don't make something be complicated with you, shouldn't you? Okay. Okay, you should commit to memory the common names of compounds you can read. Okay, so some compounds containing hydrogen are members of an important class of substance called acids. Okay, so the chemistry of this compound is explored in another chapter, but for now it will suffice to know that acid release hydrogen ions, H plus ion. Okay, when it is dissolved. Okay, and to denote this distinct chemical property, a mixture of water with an acid is given a name derived from the compound's name. So if the compound is barium acid, then here's it. So the word hydrogen is changed to the prefix hydro, and other non-metallic element name is modified by adding the suffix "ic," and the word acid is added as a second word. For example, the gas HCl, hydrogen chloride, is dissolved in water, then the solution is called the hydrochloric acid. And several other examples include, for example, you have hydrogen bromide. When it is dissolved in water, you call it as hydrobromide acid, and hydrobromic acid, I mean, or hydrogen sulfide, it will then be dissolved to make an hydrosulfuric acid, and so on and so on. Okay, great. Yep, quite many. But let's move to another topic. So many compounds containing three or more elements, such as organic compounds or catalytic compounds, are subject to specialized nomenclatures that you'll learn later separately. However, we'll briefly discuss the important compounds known as oxyacids. Okay, so what is oxyacid? Oxyacids is actually compounds that contain hydrogen, oxygen, and at least one other element, and are bonded in such a way as to impart acidic properties to the compound. Okay, so typically oxyacids consist of hydrogen combined with a polyatomic oxygen containing ion. So how to name this? So first omit the hydrogen. Second, start the root name of the anion. Third, replace the ate with ik or ite with those. And four, add acid. Okay, after it. Okay, so for example, consider H2CO3. Okay, you might call it hydrogen carbonate. Actually, this is not the correct name. To name this correctly, the hydrogen should be omitted, and the ec of the carbonate is replaced with ic, and acid is added. So the name is carbonic acid, not hydrogen carbonate. Though sometimes maybe you still find some textbook it will write it as hydrogen carbonate, but it is not how you should call it properly. Okay, so carbonic acid is the best way to call this compound. Great. So other examples are given in the following table. For example, you have HNO3. Okay, actually it's not nitrate, it's nitric acid and more. But here are some exception. For example, H2CO4 is called sulfuric acid, not sulfic acid. And H2SO3 is sulfurous, not sulfurous acid. So actually you need to commit to memory to memorize something that is exception here. Okay, great. Now we are done with this chapter. Congratulations. Now let's move to the practice part for this topic first, and then we'll do a greater review on the whole chapter. Okay. First, I want you to learn the nomenclature, the naming of the compounds below. So actually, you need to do calculations here. You only need to pay attention. Take a screenshot first. Please to do that. I'm very pleased if you do that. And you just pay attention to how to name this compound properly. Okay, it has been named as way to do it properly. Okay. The second problem is that name the following ionic compounds. So we have A, B, C, D, E. Okay, so here's the answer. So the anions in this compound have a fixed negative charge, like X minus, Sc2 minus, N3 minus, and the compound must be neutral. Okay. So because the total number of positive charges in each compound must equal the total number of negative charges, the positive ions must be Fe3 plus, Cu2 plus, Ga3 plus, and Mg2 plus, and Ti3 plus. So the charges are used in the name of the ion. So we have iron 3 sulfide, copper 2 selenide, gallium 3 nitride, magnesium sulfate heptahydrate. Okay, so the D example there's hydrate, and titanium 3 sulfate. Number 3. Name the following covalent compounds A, B, C, D. Great. So because the compounds consistently on non-metals, they will use prefixes to designate the numbers of atoms of each element. So for A, it's sulfur hexafluoride. For B, it's dinitrogen trioxide. C is the chlorine heptoxide. And D is tetraphosphorus hexoxide. Okay. Actually, you can still use hexoxide if you want, but most of the book, if A and O occurs together, it will just take the O. Okay, hexoxide. Or if there are two A, for example, what is hexa, hexaamide, for example, hexamide, like that. Okay. Okay, great for you. So there's the end of the let's practice section. Let's move to the assignment section. I want you to work out the problems first before checking your answer to the key answers. The answer key, I mean the answer key they have provided. Okay, so here's the number one, number two. Please take screenshot first. Okay, so we've done with this part. Okay, today's lesson, and we'll do great review on the first chapter. Okay, are you ready? Okay, sure. So first, classification of the following as an element, a compound or a mixture: iron, oxygen, mercury oxide, pancake syrup, carbon dioxide, a substance composed of molecules of which contains one hydrogen atom and one chlorine atom, baking soda, baking powder. So actually, you just need to identify it, and it's very simple. You should check it again how to identify if this is compound, the mixture, element. This is on the I think of first and second video I think, and you should read it again. And after reading it, I think you will understand how to classify it using the scheme that I have showed you before. So yeah, respectively there are element, element, compound, mixture, compound, 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 mixture. Okay, I will not explain to you because you need to work it out. Okay. Number two, when an elemental ion corrodes, it combines with oxygen in the air to ultimately form red-brown iron trioxide called rust. So A is a shiny iron metal. A shiny iron nail with an initial mass of 23.2 grams is weighed after being coated in a layer of rust, which expect the mass to have increased, decreased, and remain the same. Explain. B. If the mass of the iron nail increased to 24.1 grams, then one mass of oxygen combined with the iron. Okay. So here's the solution. So for A, we will expect the mass increase will have combined with oxygen in the air, thus increasing the amount of matter in the mass too. And for B, the mass of oxygen combined is you just need to subtract two numbers, 24.1 with 23.2, which gives us 0.9 grams. Okay. Number three, classify each of the following chains as physical or chemical. A consists of steam, B burning of gasoline, C souring of milk, D dissolving of sugar in water, E melting of gold. So yeah, actually it's very easy, physical, chemical. Okay, if there's no nothing that related to chemical chains, the chemical property chains after the reaction or the changes, then it will be physical. Okay, so respectively, A is physical, B chemical, C chemical, D physical, E physical. Number four, identify whether the volume change of a sample of oxygen gas from 10 milliliters to 11 milliliters as the temperature change is a chemical or physical change. Yeah, it's very clear that this change doesn't involve chemical change. Okay, chemical property change. So this must be physical change, right? Number five, please pay attention to the figure shown in the slide. So in the drawing, the green spheres represent atoms of certain element, and the purple spheres represent atoms of another element. So if the spheres touch, they are part of a single unit of compound. So does the chemical change represented by these symbols violate any of the ideas of Dalton's atomic theory? If so, which one? So here's the solution. The starting materials consist of two green spheres and two purple spheres, and the product consists of only one green sphere and one purple sphere. Then this clearly violates Dalton's postulate that atoms are neither created nor destroyed during a chemical change, but are merely redistributed. So actually, yeah, you have watched before that the atoms in this case appear to have been destroyed. Okay? This must violate Dalton postulate. Okay. Number six, problem six. A sample of compound A, a clear colored gas, is analyzed and found to contain 4.27 grams carbon and 5.69 grams oxide of oxygen. And a sample of compound B, also clear colored gas, is analyzed and found to contain 5.19 grams carbon and 3.84 grams oxygen. So this data of an example of the law of definite proportions, the law of multiple proportions, or neither. And what did this data tell you about substances A and B? So actually, we can mention that in compound A, the mass ratio of oxygen is shown, and in compound B, the mass ratio of oxygen to carbon is shown. And these ratios both different. Okay, so but you can also pay attention that if you make a ratio out of these ratios, then you get 1/2. And this supports the law of multiple proportions. This means that A and B are different compounds, with A having one half as much oxygen per amount of carbon, or twice as much carbon per amount of oxygen as B. And then a possible pair of compounds that would fit this relationship will be A is CO and B is CO2. This is just example. You can find many more compounds that fit. Okay? Number seven, write the empirical formulas for the following compounds. Okay, please pay attention to the figure on the right side. Okay, so actually very easy, right? You just need to count the number of carbon, hydrogen, oxygen atoms in this structure, and you find C had 4, H had 8, O with 2, and the simplified ratio is 4 by 8 by 2, which is 2 by 4 by 1. Therefore, the empirical formula for this structure is C2H4O. Done. Number 8. Write the formulas of the following compounds: rubidium bromide, magnesium selenide, sodium oxide, and calcium chloride. Okay, so yeah, you just need to actually first identify Why is the ion? Find out how many of each ion you need to neutralize the process, and you can write down the compound. For example, for A, you have RBBR, for B, you have MgSe, for C, you have Na2O, and for D, you have Cl2. Number 9. What are the IUPAC names of the following compounds? Manganese dioxide, mercurius chloride, and ferronickel. So oxide has two minus charge, and there are two of them. It means manganese must have four plus charge. So the proper name is manganese for oxide. For mercurius chloride, actually this is the wrong name. Okay, mercury must have, because chloride has one negative charge, then mercury must have one positive charge. So the correct name is mercury one chloride. And for C, nitrate has one minus charge. Okay. Uh, so the Fe part should have a 3 positive charge because there are 3 of NO3 minus. Hence the proper name is iron 3 nitrate. Number 10, the last problem. Write a symbol for each of the following neutral isotopes. Include the atomic number and mass number for each. So the first one is the alkali metal with 11 protons and a mass number of 23. And B is the noble gas element with 75 neutrons in its nucleus and 54 electrons in the neutral atom. Actually, you need to pay attention to the IUPAC periodic table. So that's why I always want you to have periodic table on your hand. Okay. So first one, atomic number is very clear, right? Which is equal to the number of proton, 11. And then the mass number also given, which is 23. Then you can write it as 2311 Na. For B, the noble gas element with 75 neutrons. Okay, so the atomic number is the number of proton is equal to the number of electrons too, because this is a neutral atom. So the atomic number is 54, and the mass number is just the sum, okay, the sum of neutron and proton. So 75 and 54, which gives us 129. So therefore the symbol for the neutron isotope is 12954 Xe, xenon. Okay, xenon. Done. So here's the assignment for you, the review assignment. Number 1, take a screenshot. Number 2, please take a screenshot. Number 3, please take a screenshot. Number 4, number 5. Great. So after do it by yourself, then choose the review answer for you. Okay, good. So that is the lesson for today. So here's inspiration, the quote for you. So Maya Angelou once said, stepping onto a brand new path is difficult, but not more difficult than remaining in a situation which is not nurturing to the whole man or woman. Okay, so thanks for watching. Here's your to-do list. Subscribe, give a like, comment, share this video. And I'll be back every Tuesday and Thursday. So keep watching my video. And once again, I want to remind you to visit my website, to our website on https colon forward slash science with xyz.unaux.com. And there are many free learning resources, PDFs that you can download it, extra PDFs for you, bonus one. Okay. So that being said, thank you and goodbye. See you on the next video.